All right, guys, so I'm sorry for what happened last period. Luckily, I'm in a room with nobody, so I can actually take my mask off so you can hear me clearly. Okay, so I don't know where we left off, so I'll just quickly go over this. If you want, you could skip forward and go to the part that you missed. So here we have the sun, here we have the earth, there's the gravity connecting the two of them. So what we said is that Einstein comes up with this idea that the sun disappears. If the sun disappears, then the gravity that it's generating will also disappear. But the light that came out of the sun as it disappeared will still exist. The light doesn't cease to exist because the sun is gone. It's just not making any more light. And so that light is still got to travel that distance from the sun to the earth. So if we're looking at that, what we're talking about is that 8 minutes of lag time. Now, according to Newton, if this happened, the very second that it happened, the Earth should shoot off in a tangential direction. You guys learned about tangents in math, okay? That's what Newton says. Einstein says that's impossible because there's no way that the gravity or lack of gravity can travel faster than the speed of light. According to Einstein, the Earth still has to travel at least 8 minutes in its path before it can disappear. Okay? And so what ends up happening, because the light still has to travel to us, so that 8 minutes of lag time still has to pass and get to us. So the Earth has to be in shadow before it can shoot off into space. And what happens? This is exactly what we prove to be true. Gravity does not travel instantly. Gravity, at best, travels at the speed of light. And eventually, we actually were able to figure this out, that gravity travels as waves, what we call gravitational waves, across the void of space at the speed of light. Now, this presents a problem for Einstein, because Einstein now has to falsify Newton, but falsifying Newton isn't enough. When you falsify a theory in science, which happens all the time, which is part of science, okay? When you falsify a theory, it's not enough just to say this is wrong. You have to say this is wrong, and you have to prove what is correct. And that's what Einstein's going to do next. Okay, so Einstein has this problem, and he works on it, and he works on it. He works on it for more than a decade. And what he ultimately comes up with is he realizes that when we look at the universe, we have 3 dimensions. Length, width, and height. Those are the things that we can move in. We basically just call that space. Okay? But he realizes that there's something else that we move through as well, and that is time. And so that's the 4th dimension of time. And what he does is he realizes that all put together, these things actually act like a fabric stretching across existence. And he calls this space time. Now, what does that have to do with it? Well, what he realizes is that what gravity actually is bends, curves, or dents in space-time. And so what he says is when you take an object that has mass, okay? So if you have an object like the Earth, that object exists in space-time. And what that object is going to do is it's going to bend space around it. Like that. And so it's going to create a dent in space and time. Now I'm going to show you an example of this. Okay, so here's our simulation of this fabric of space and time. I have my daughter's t-shirt. And so what happens is you see it's a very stiff fabric here. And what Einstein basically says is that if you take an object with mass, like this, or this, and you put it in that fabric, it's going to make a dent. Now, little objects like this, you can see how it sags a little bit right here, right? If I add some more weight, you see that the dent gets deeper and deeper. If I add a lot of weight, you see once I take the weight off, see how it snaps right back into place? If I add something that's very heavy, like this guy, you see that the dent gets deeper and deeper and deeper. what we experience as gravity is just us following these curves. So for example, if I take this little ball here and I roll it, you see how it rolls down? It falls in towards the curve. You can see, if we look at it here, you can see the depth of this. I know it's not the most high-tech example, but it works. It will keep going, and if I give it enough speed, see, if I don't give it enough speed, see how it rolls back? But if I can give it enough speed, it will actually, see now it's even deeper because there's even more weight in there. And it falls down faster and faster. In order to get out of this dent, I'd have to give it a ton. And so ultimately what Einstein realized is that the size of the dent that you make is proportional to the mass. So here we have the moon, very small. You see the size of its dent. If we go over to the Earth, much more mass, you see a much bigger dent. You can compare the masses of these two. They're on the front of your reference table on that same chart as the speed of light. And if we go over here, you can see that the sun is going to make an incredibly huge dent. And so if we take a step back, you can see as the mass of the object increases, so does the depth of the dent. And that depth of the dent is what we call the strength of gravity. Why? Because if you want to get out of here, well, you got to go like this. Think of it like a skateboarding ramp. Okay, if you want to make your way out of that skateboarding ramp, you got to be traveling pretty fast to get out. Otherwise, you're just going to rock back and forth and back and forth. For this one, you got to go even faster. And for this one, you have to go even faster. The speed at which you have to go to get away from these objects is what we'll call escape velocity. And we'll get to that tomorrow in class. But this is the basics of what you guys missed in the last couple minutes, along with some extra stories.